guys, welcome to video 2 on solving linear equations. So if you haven't checked out part 1 yet, I'll go back and check that out first and then come back and play with this one, because we're dealing with slightly trickier equations here, mostly ones containing either fractions or brackets, or even brackets and fractions. Okay, so let's get cracking. Okay, so for the first example then, we've got an equation involving brackets. So what we need to do with these first of all is to expand the brackets and then simplify what we get on the left hand side. So with the first bracket then, 3 times x is going to give us 3x. 3 times minus 4 will give us minus 12. And now we've got minus 2x minus 8. So when we minus a bracket, that's like having a minus 1 on the outside, multiplying everything on the inside. So minus 1 times 2x will give us minus 2x. And then minus 1 times minus 8 will give us plus 8. And then that's all equal to 6. Okay, so we've done the expanding. Now we need to simplify what we've got going on the left hand side. So as far as the x terms go, we've got a 3x minus 2x. So that's going to leave us with 1x. And then we've got minus 12 plus 8. So that's going to leave us with minus 4. And then that's equal to 6. And then if we add the 4 to the right hand side, it disappears on the left, and we get left with x is equal to 10. Jobs are good and we've solved the equation. Okay, next example. 2 lots of x minus 5 equals 42. So again we need to expand the bracket and then solve. So 2 times x is going to give us 2x. 2 times minus 5 is going to give us minus 10, and then on the right we've got 42. So now if we add that 10 to both sides, we're going to be left with 2x equals 42 plus 10 is 52, and then we need to divide that 2 that's stuck on the x. And that will leave us with x equals 26. That's a good one again. Okay, example 3. So again, we've got 2 sets of brackets here. So we're going to need to expand and then simplify the left hand side. So looking at the first bracket, 5 times 1 is 5. 5 times minus x is minus 5x. That's the first bracket done. Now looking at the second bracket, 9 times x is going to give us 9x, and 9 times 7 will give us 63, and then that's all equal to 108. Okay, so if we now simplify the left hand side, so we've got a minus 5x and a plus 9x, so 9x minus 5x will leave us with 4x. And we've got a 5 plus 63, which will give us 68. So we've got 4x plus 68 is equal to 108. Okay, so we've expanded and simplified the left hand side. Now we need to solve the equation. So let's first of all take away the 68. And that's going to leave us with 4x equals 108 take away 68 will be 40. And then finally for our last step, we're going to want to divide by the 4. And then that will leave us with 1x is equal to 10. So that's the equation solved. Okay, let's check out some then where we've got a fractional x term. So, very much like this example here. So we've got 3x over 2 plus 1 is equal to 13, and we need to find the value of x. So the rules are the same really as when we were solving the simpler two-step equations. Where we can, we always want to move the middle term first, the term that has nothing to do with x. So our first step here then is going to be to subtract 1 on both sides. Now that's going to leave us with 3x over 2 is equal to 12. Now we have a choice here, so 3x over 2 is the same as 3 halves multiplying x. So we could divide both sides by 3 halves, but that's probably not the coolest way to do it. That would probably lead to some quite tricky calculations. So let's do it step by step. So what we've got going on, we've got 3 times x, and then that's being divided by 2. So I would always move the bottom of the fraction first. So it's a division by 2. So to sort him out, we're going to multiply both sides by 2. And that's going to leave us with 3x equals 24. So the number up on top of the fraction doesn't get multiplied by 2 there. Remember, it was already being divided by 2. So by multiplying by 2, we've cancelled out that division. So we've now got 3x equals 24. So to move the 3, we want to divide by it. And that will leave us with x equals 8. Because 24 divided by 3 is equal to 8. Cracking. Okay, 5x over 4 minus 10 equals minus 20. So again, let's move this bit first. So to move a minus 10, we're going to add 10 to both sides. And that's going to leave us with 5x over 4 equals, now minus 20 add 10 is going to take us up to minus 10. And again, really, I would recommend moving the bottom of the fraction first. So that's a division by 4. So to move it, we're going to multiply it by 4. And that's going to leave us with 5x equals minus 10. Minus 10 times 4 is minus 40. And then finally our last step, to move that 5, we divide it away. And that will leave us with x equals minus 8. Because minus 40 divided by 5 is minus 8. Okay, 8x over 3 add 6 equals 0. So again, always move this bit first. So we're going to subtract 6. That's going to leave us with 8x over 3 equals minus 6. Let's move the bottom of the fraction first. So multiply both sides by 3. That leaves us with 8x equals minus 18. And then finally, let's divide by the 8. So that will leave us with 1x is equal to minus 18 divided by 8. Now again, there's nothing wrong with leaving your answer in terms of a fraction, but where you can, you always want to simplify them. So here, between the top and bottom, we've got a common factor of 2. So 18 over 8 can be written as 9 over 4. But it's a minus 9 over 4 because we've got minus 18 over 8. As a decimal, that would be minus 2.25. But as I say, absolutely nothing wrong with leaving your answer in terms of a fraction, as long as the question doesn't ask specifically for a decimal answer. Okay, so now we're looking at equations where we've got more than one term on top of a fraction. So one like this where we've got x plus 1 all being divided by 2 is equal to 9. So it's important to realise here that both terms on top of the fraction are trapped by that 2 on the bottom. So the whole thing, x plus 1, is being divided by 2. So we can't start off here by subtracting 1 because it's trapped by the bottom of the fraction. So the first thing that we have to do here is to sort out the bottom of the fraction. Now remember, it's a division, so to sort that out, we're going to multiply both sides by 2, and that's going to give us x plus 1 is equal to 18. Again, remember the x and 1 don't get multiplied by 2 because they're already being divided by 2, so we've simply cancelled out that division by a multiplication. And then there's one final step for us to do here, and that is to subtract the 1 from both sides. That's going to leave us with x equals 17. Job's a good one. Okay, so here we've got maybe a slightly trickier one, but let's run through and attack it. So again, we can't do anything about that minus 5 yet because it's trapped by the division, by the bottom of the fraction. So the first thing we have to do is cancel out that division by 3. And to do that, we multiply both sides by 3. So that will give us 7x minus 5 equals 3 times 17, which will give us 51. Okay, so now we've cancelled out that division. We're back to a normal two-step equation. So we're going to sort out the minus 5 first. So we're going to add 5, and that will leave us with 7x is equal to 56. And then we're going to divide by 7, and that will leave us with x equals 8. Cracking. Okay, another slightly trickier one then. So this time we've stepped it up again. We've got a negative number over on the right hand side. So our very first step is to cancel out that division of 7 on the left. So we're going to multiply both sides by 7. That will give us 2x minus 5 equals minus 4 times 7 is minus 28. Now we're going to want to add the 5, which will leave us with 2x being equal to minus 23. And then finally, if we divide by the 2, that's going to leave us with x equals minus 23 over 2. Again, you're absolutely fine to leave your answer in terms of a fraction, but just in case you wanted that as a decimal, it would also be minus 11.5. Cool. Okie dokie. So, stepping it up again slightly here, we've got a fractional term and just a normal number on its own. So the way that I would recommend we attack this would be to move this plus 2 first. We could actually get away with multiplying by that 2 first as well, but I'm a fan of getting as many things on the right hand side as I can before I start messing with complicated terms like this guy we've got here on the left. So to move this plus 2, we're going to want to take it away, and that will leave us with 3x plus 7 over 2 being equal to 7. Okay, so now we can carry on as we have in the previous questions. Let's multiply by the 2, and that's going to leave us with 3x plus 7 equals 14. Now if we take away the 7, we're going to get x 3x equals 7. And then finally, if we divide by the 3, that's going to leave us with x equals 7 over 3. Which as a decimal isn't very nice. It would be 2.3 recurring. So that is definitely a nicer one to keep as a fraction. Okay, so we might also get a cheeky question like this where we have brackets and a fraction going on. So I would always move the bottom of the fraction here before I attack the top. So my first move would be to multiply by the 3. That just gets rid of the fraction and I think makes things look less scary. Okay, so up here then. Hey guys, so the last example for this video, here we've got a cheeky mix of brackets in a fraction. So we've actually got a choice as to what we could do for our first move. We could either expand the brackets up on top, or we could multiply by the 3, which would get rid of the fraction for us. That would always be my choice of first move, because I think as soon as you eliminate the fraction, things start to look simpler. So my first move here then would be to multiply by 3. Now if we do that, we're going to be left with 10 lots of 3x plus 4, and that's all going to equal 6. Okay, now we've got another choice at this point. We could divide by the 10 straight away and get 3x plus 4 equals 0.6. But then we're dealing with a decimal or a fraction depending on how you keep it. So in this instance, I wouldn't take that route. I would expand the brackets now. So doing that would give us 30x plus 40 is equal to 6. And now we're going to want to take away the 40. That will leave it with 30x is equal to 6 minus 40 is going to be minus 34. And then finally we want to divide by 30. So that will give us x is equal to minus 34 over 30. Which can be simplified to minus 17 over 15, which we can even write as a mixed number in the form minus 1 and 2/15. Cracking. Okay guys, so if you found that useful, head on over to part 3, where we're going to be looking at how to approach questions with an x on both sides of an equation. Cheers!